Today I shall give video lecture on subsystem design process and illustration. At the end of this unit we'll be able to understand consideration to be made for designing, problems associated while designing and few solutions for the problems, design process and design of 4-bit shifters, design of ALU subsystems and various adder circuits. General consideration. Before going into general consideration to be made for designing, let us know what is subsystem. Subsystem is a small unit block of a complex block. Example, let's consider a full adder as a complex block. We know full adder can be constructed using two half adders. Therefore, half adder acts as a sub-block through which a complex block, that is full adder, can be built. General consideration to be made before designing any system. As a users, we need to purchase any system. We'll look for its cost, performance, battery life, its weight, etc. As a designer, we have to fulfill users' requirement. Therefore, while designing a system, we have to design a system which has lower unit cost, high reliability, that is longer life, low power dissipation, which increases the battery life of the system, low weight and low volume, better performance in the sense speed. It should perform better. For example, if you take a smartphone in which we want to perform or we want to play a game, if the performance of the smartphone is less, then the user for that particular smartphones will be very much less, because we look for the performance, the speed. While playing, it shouldn't hang. So the system should provide better performance. As a designer, we have to look for better performance circuits, designing better performance circuits. Enhanced repeatability. Enhanced repeatability is once the subsystem is designed, it can be used in designing other systems. That is, same subsystem is repeatedly used for designing other systems. Possibility of reduced design or development period. We have to look into reduced design as well as development period, so the time to market will be fast. Some problems associated while VLSI design are as follows. How to design a complex system in a reasonable time and reasonable effort. If the system is not designed in a reasonable time, then time to market, that is available of your system in the market, will be delayed. Hence, the demand for the system might also reduce. The nature of architecture best suited to take full advantage of VLSI and the technology. Many architectures are available. Example, CMOS, BiCMOS, NMOS, etc. Each architecture has its own advantages as well as disadvantages. Hence, we have to choose the architecture that gives the best advantage for our design. The testability of large or complex system once implemented on silicon. Once implemented, chip contains millions of transistors and hence testing of complex system is difficult. There are few solutions for the problems stated. The problem 1 and 3 are generally reduced if two aspects of standard practice are accepted. Top-down design approach with adequate CAD tools to do the job. Complex blocks can be subdivided into sub-blocks and these sub-blocks can be divided into leaf cell. This process is called as top-down design approach. We can use a CAD tool for designing these complex blocks. which reduces the time and the reasonable effort for the designer to design a complex system. The CAD tools can be like a Xilinx with a Verilog for designing digital circuits, or it can be a cadence tool for designing analog circuits. Partitioning of the system sensibly. We have to partition the systems, or the sub-blocks should be sensibly partitioned, aiming for simple interconnection. All these sub-blocks should be placed nearby such that the interconnection to form a complex block should be easier. High regularity within subsystem. High regularity means simple and similar blocks. Each subsystem should be verified before building a complex block so that testing complex block will be easier, or fault can be diagnosed at subsystem level. This is what a generate and then verify each section of the design indicates. That is, once the subsystem is designed, each subsystem has to be verified before designing a complex block using these subsystems. Devote a significant portion of total chip area to test and diagnostic facility. That is, a portion of the chip will be kept aside for testing purpose. For example, in the TV remotes, we might have seen different color buttons. These color buttons are used for testing the networks availability in your TV or cable channels. Select architecture that allow design objectives and high regularity in realization. Illustration of design process. Structured design begins with the concept of hierarchy. The concept of hierarchy indicates a top-down design approach. That is, a complex function is subdivided into subfunctions, and then the subfunctions is divided into a leaf cell. As system complexity increases, its organization changes as different factors become relevant to its creation. That is, a coupling can be used for measuring how much subblocks or submodules are interacting each other. These submodules which are interacting each other can be placed at one place so that interconnection between them will be easier. It is crucial that components interacting with high frequency be physically proximate. That indicates the components which is operating at higher frequencies might interact with the other blocks, and it might create some distortion, or the chip will become faulty. Hence, the system which is operating at higher frequency must be kept apart from the other blocks. So it should be physically proximated. Concurrency should be exploited. That is, no gate or the circuit should be idle at any given time. It should be performing some useful function at all the time. Because technology changes so fast, the adoption to a new process must occur in a short time. That is, once a subsystem is designed, it should be adaptable for new technologies. For example, at present we are on 14 nanometer technology. Now their work is going on for 7 nanometer technology. Once 7 nanometer technology comes, then this circuit or subsystem which is designed for 14 nanometers should also be applicable, or should also be implemented at 7 nanometer technology. Approaches used at different stages of designing. First will be a conventional circuit symbol, then a logic symbol, stick diagram, mixture of logic symbol and stick diagram that is convenient at a stage, mask layouts, architectural block diagram, and floor plans. Conventional circuit symbol is nothing but the circuit design using a transistors. Logic symbol indicates the symbol. For example, it can be a NAND gate which acts as a logic symbol. If NAND gate is designed using a transistor, that acts as a circuit symbol. For this logic symbol, we are going to write a stick diagram which will be convenient for designing a layout which is used for fabrication. These layouts are again floor planned. Floor plan is nothing but placing of different components at nearby places which will become convenient or easy for routing purpose. Thank you. The other topics will be covered in subsequent videos.